EDABuilder, EMA's new solution for creating schematic symbols and IPC-compliant PCB footprints. Kelly introduced me as Ron Smith. I also go by Smitty, and joining me today is Mike Bitsko, who is the product developer. As we're all probably aware, component creation is a fundamental and integral part of any CAD system. And as such, you would expect that CAD vendors would have the ultimate library solution. However, as many of us experience, that's not always the case. So today, exploring alternative library development is the focus of this webinar. So EMA Design Automation was founded in 1989. We were selling at that time the CAD du jour, and we began selling Cadence software as a channel partner in 1998, and in 2003 became the only reseller of Cadence tools in North America. Understanding that electrical and mechanical design disciplines are tightly intertwined, in 2009 we also became an Autodesk or authorized reseller. So leveraging these two technologies, EMA can provide solutions to engineers facing design challenges within actually all organizations. Kelly, can we do our first poll? So the question here is about your organization and how you currently do library development. And if you could just take a minute to give us your reply, I'd appreciate it.
Okay, thank you.
So as we begin, I'd like to first highlight some of the challenges that we hear individuals responsible for creating library parts often face. We'll then focus on how EDABuilder addresses those issues, first with some overview slides and then an actual software tour. I'd then like to just take a couple minutes to mention the new OrCAD Marketplace and its functionality, its capabilities, and the resource potential that it actually serves you. And then lastly we'll just wrap up and bring the webinar to a conclusion. So we have another polling question that we'd like to get your feedback on at this point. So as I mentioned, the topic that we're first going to address is challenges, and so that's really what we're asking here. What are some of your challenges that you face?
Okay, we'll just let a few more people vote. Okay, Ron.
So I noticed that there were a third of you that were replying the fact that a release process and version control is something that may be missing. EDABuilder today does not address that exact problem. If you attended the webinar that we had on Tuesday for CIS and CIP, those tools would actually accomplish that, and tied in with EDABuilder become a full solution. So, as some of those challenges exist, I would say most often CAD tools actually have two independent environments, one for logic symbol creation and the other for PCB footprints. And each has its dissimilar or has a dissimilar editor. They require the person doing the library development to have the same skill set as the CAD designer themselves, and oftentimes that is the job of the CAD designer. But a lot of times those tools are non-intuitive and unproductive. Possibly your current tools do not support standards like IPC 7351 or even your own internal company standards. They force you to create parts based on the limitations of the CAD software. Very few CAD vendors tools actually support chip vendor PDF datasheet extraction. And if they do, it's often a very expensive option. So what one does is call up a datasheet as a reference document and manually go about re-entering the information into the CAD library tool. It's very time-consuming and error-prone. Each of us have had our own methods for creating libraries in the past. When it comes to PCB footprints, there are times when you might call up a PDF drawing, get the XY coordinates there, and just enter the XY coordinates into your PCB CAD library tool to position those pins. That's fine for a 20-pin dip or something like that, but when you get into parts that have 500 to 1,000 pins, that is very time-consuming and, like I said, very error-prone. Some companies actually, for creating the land patterns, would create almost a one-to-one pattern of the actual part itself, the chip itself, to determine what the ultimate pad should be to recognize the toe and heel dimensions. And again, that's a very time-consuming, laborious process. When it comes to schematics, we probably all have, well, if our tool allows us to, we probably all created Excel spreadsheets where we enter pin names, pin numbers, and then go about maybe cutting and pasting that into the schematic tool to create the symbol, or if we're lucky, maybe read in a comma-separated file. So we all have our own ways of having done things in the past, but what we're looking for is a tool that automates that process. So because CAD libraries are developed in independent editors, there really isn't a way to verify the schematic symbol with the PCB footprint until the design is either netlist or packaged into the board, when you might discover that the two aren't compatible. And that happens quite frequently. So again, a tool that will address that is of utmost importance, and that is indicated by the highest results of the poll question, where 71% of you said verification is the most critical element. And then another possibility is that you may, at your company, have requirements to support multiple CAD formats. Often companies have multiple CAD tools, CAD systems, and libraries that are developed in one cannot be easily shared or ported to the other systems. So that's a challenge that a lot of companies do face. And so what we'll talk about today is the solution, EDABuilder. Kelly, could you pop up another poll question for us, please? I'm just curious how much time you actually spend in library development. Obviously, it depends on the project, the number of parts that have to be created from scratch, whether or not you're doing a respin of a board, those type of things, but just kind of some general comments.
Okay, Ron, poll is closed.
Okay, so typically the most frequent answer there is that it takes people or you 2 to 3 days to create library components for a new project. The least is is more than 2 weeks. So I'm glad to hear that you aren't spending your life just developing libraries, but even several days to a week is a very important factor in trying to be more productive, and you could be using your time on something that's more creative. So as I had mentioned earlier, CAD vendors typically have 2 different editors for schematic symbol and for PCB creation. In our case, EDABuilder is one application that allows PDF data extraction, the creation of pin tables, and pin tables are really the heart of this. It almost goes back to that Excel spreadsheet type form that can then be automatically partitioned into the logic symbol or done interactively. And then finally creating the IPC compliant footprints. So all this is done in one tool with other features like linking library, so you have pointers from the logic symbol to the footprint. You can share attributes between the symbol and the footprint, and you can also do cross-probing to highlight elements. So the footprint generator uses mathematical equations to calculate the land pattern dimensions and the pad stack sizes. And again, this would be to generate IPC 7351 compliant parts. And EDABuilder actually ships with many common package calculators, or what you might consider to be a template, so that you can choose the particular package style you want, and then you'll be presented with forms that allow you to add the dimensions to those forms according to that part. And if your company does have the need to do multiple exports, both on the logic side and on the footprint, we do allow targeting to export to those other vendor libraries. So library development is actually a process, and you probably will all gone through this. It begins with the manufacturer component data sheet, as indicated here on the screen. The challenge here is to automatically and intelligently get the data into your library tool. So EDABuilder's success here is based on the advanced PDF data extraction functionality or capability. So again, this is an example of a pin table coming from the PDF data sheet. And we can extract pin tables that span multiple pages, as well as graphical diagrams and VGA maps, just to name a few. What you're seeing on the screen here is EDABuilder. There's 3 windows that are actually present there, and we'll discuss those as we go forward into the demonstration. So here's really where we want to get to from the data sheet, is an intelligent spreadsheet that contains information that we want to move forward into the logic symbol graphics. So by going through some commands here, we can then automatically or interactively create the logic symbol. And then from this point, as you can see on the menu bar, there's an export menu pull down. Here's where we would export to the host CAD system that we want to target. And the last window here is the footprint window pane, where you can pick from the calculator a package template to create that the required footprint. And by entering dimensions from the data sheet into the available fields, EDABuilder will then calculate the required package and pad stack sizes. And again, there's the export. It's kind of hidden behind the menus here. Maybe 1 second. There's also an export button there, which would again allow you to target to your particular host CAD system. And Callie, I think we have just 2 final polling questions that are linked together, and if you could just present those at this time, that would be helpful.
Okay, and here's our final question. We're just interested in learning what CAD formats you need to build PCB footprints.
So as I would have expected, obviously this audience is weighted towards OrCAD Allegro environment, but as we understand, there are the needs to export to multiple CAD formats, and we do address that.
Okay, Ron, we're all set.
Okay. So at this point, we'll take a live tour, and now you're going to make me work for this presentation. So I'm going to switch over to another window where I'll just bring up the EDABuilder tool. So EDABuilder opens with 3 window panes, providing you choose to do both logic symbols and footprints. There's the main window that you saw from the slides, which is the PDF extraction and the spreadsheet window. And then there's also in the upper right here, the graphical view of the logic symbol that gets created, and the bottom one is the PCB footprint. You can switch between any of these particular windows, and if I wanted to, let's say, just go into a full screen mode of the footprint builder, I could tab that, and now I'm just in the footprint builder. Or alternatively, I could go back to configuring both logic symbols and footprints. So we're working in one application for the creation of all the necessary elements of logic symbol and footprint creation tied together. All right, so as I had mentioned, what I'll do here is I'll just switch to symbol builder so that I can enlarge my panes, my window panes. And the heart of the tool is the ability and the advanced capability of PDF datasheet extraction. So by clicking on PDF datasheet extraction, I can then open up a PDF file. In this case, we'll take a Cypress network processor. And as I had mentioned in the PowerPoint presentation, we could go through and extract pin tables that span multiple pages. We could go through and we could do diagrams like this and extract the data from the diagram, multiple different types, or we could do VGA bitmaps as well. In this particular example, we're just going to do the extraction of a pin table for purposes of time. And for those of you that find this webinar useful and you want to do some further exploration, or you ultimately buy the tool, we're going to be having webinars here where we'll actually get into different technologies and different examples of ways to process different types of data sheets into the symbols, as well as creating different and more complex footprints. But today, for the hour constraint that we have, we'll just do this from a fairly simplistic example. But in this particular instance, what I want to do is I want to actually do some extraction now from the data sheet. So I'm going to go to the editor tool, and there's pop-ups that occur when you pass your cursor over these icons, and the first one is create a table. And so by clicking that and looking at the prompt at the bottom of the screen, it says enclose the area of the table, left mouse button, move the cursor, drag and release. So what I'm going to do is just grab this particular table. And at that point, I can complete the table. Now, there might be data inside this table that I don't want to have. I want to pass information that's going to be pertinent to the spreadsheet and ultimately to the symbol. So if I can get rid of blank rows or extraneous data, it'd be helpful if I can do that here. And I can by just tagging those particular rows that I don't want to include. If there was something else down here, I could exclude those as well. At that point, or at this point, I could actually pass this data to the spreadsheet. And this is just a pin table spreadsheet. It's not a BGA that we're creating here. So I can just copy to the spreadsheet. I get a message that said there are 18 rows that are being copied. And to view that data, I could select the Scratch Sheet tab. So there's my PDF. If I select the Scratch Sheet tab, here's the data that has been now condensed into a spreadsheet for us to continue working with. So some of the things that I have to do with this is, you notice that there's some elements that are red. Well, to me, that would indicate that there is something wrong with that particular data. And one of the things that's wrong with it is that we might have things like, let me zoom in a little bit here. We might have things like pin names that are, or signals that ultimately need to be negated. So depending on the CAD system we're going to, we might have to provide a provision to rename that particular signal name or pin name with something to accommodate the overbar. Or down further, we'll see that we have a field that would be normally your input, output, the pin type or pin direction as communication network interface. And so if I go back to that data sheet, you'll see that that particular one is highlighted in red as well. So what I'm going to do here first is I'm going to just tag the columns to identify those elements that I want to take forward to the main spreadsheet. So if I go to column tags, I can then click headers for those columns. So pin name, this would be the pin name that I want to tag. Pin number. You notice that there's a bunch of pin numbers in here, and that's because this data sheet was giving you the pin numbers for different package styles. There's a 64 pin QFP, there was a 44 QFP in that data sheet, as well as an SOIC. I think it was maybe a 32 pin SOIC. So I'm just going to click the column that pertains to the 64 pin QFP. So that's pin number, and then direction. I can tag the direction. And you'll notice that there's a bunch of different other categories here depending on the type of data sheet that you're processing. So if it has differential pairs defined, or if you're doing something like an FPGA and you have banks that you want to identify, you can do that. You can do things like merging columns, etc., to create unique pin names, those type of things. And so the red, let's get maybe do some correction there for map negation codes. It's asking me to select a column and then map those. And you'll notice now those particular red pin names went and were converted to just _L so that we can accommodate them in the particular capture pack or the schematic package that we're wanting to export to. We have the pin direction, we have the number, and we could address this now, but I'll just go forward with, let's say we didn't see that as being red, and I'll just take this to the next level. So what that means is I want to move this data to the main spreadsheet, which is the final spreadsheet that we would then go into this symbol with. So take this forward to the main spreadsheet. Going back to the main spreadsheet, I now have 18 rows of data or whatever it is, and I want to do a check of this particular data. But before I do the check, I know I've done this many times. Well, here, I'll do it. So I do a check, and it tells me that this is a new part, so let's save it to the library. So I'm going to do that. I'm just going to say File, create a new envelope. And an envelope is a directory area that contains multiple elements. It could contain the PDF data sheet. It's going to create the actual XML file to create this particular part, etc. So here I can identify some name for this particular component. I'll call it _web. And I can put it into a particular library. We didn't talk about settings or setups, but you can define your own libraries, path to them, and so I created one called My Symbols, and that's where I'll port this to. It's telling me that it's being written to that directory path. So now if I do a check, I get another warning message that says there's an invalid pin direction code, and again that's highlighted here. So if I look at that, that was that communication network pin. It's not one of the typical pin types. if I do a right click by highlighting that box and say fill, I could change it to one of these others. In this particular case, I'm going to call it a bidirectional pin. Again, if I do a check, I get some other warnings. But you'll also notice that when I did that, it expanded the bits. We flattened the bits to accommodate each actual independent bit. So the warning messages that we got here were that we have duplicate pin names. So some CAD systems do not handle multiple pin names being identical. So they have to be incremented in some way. So we can do that automatically. And then we're also getting a message here that our VDD and VSS pin names are identified as an input, but the name suggests that they're going to be power and ground. So not all data sheets are correct. And if we go back to this data sheet, you'll notice that VDD in actuality was defined as an input, VSS as an input, VPP as an input, when really they should have been power and ground. So I'm going to change those. And to do that, first of all, I'm going to take care of the sequential pin names. So I'll create unique pin names for VDD, VSS, and NC. Create unique pin names. And now you'll notice that they have been appended with a sequential number to make them unique. And then the other thing that I want to do is actually change these pin types. And again, by highlighting the boxes, you can do a click and drag, right mouse click. I want to fill those with whatever pin type it is. In this case, it's power. The VSS are going to be ground. And the VPP I'll make power as well. And so now if I do a check, I have 64 pins, which I would expect to see, but I have 64 pins, and there are no warnings or errors. So that's a good point. We have pin numbers, pin names, and we have a direction code. Really, that's all we need to create logic symbols. So at this point, I can go forward and I could actually create the symbol. So I could do that one of several different ways. I could do it, and I'm going to go back for a second here. I could do that automatically, so I could say I want to assign these particular pins to a symbol, and I want you to do it automatically. And the automatic configuration that's there is pin assignments. Typically, inputs are on the left, outputs are on the right. Power pins could be on one symbol, or they might be on a unique symbol to house those particular pins, as well as NC pins. You can do some configuration in terms of the number of pins you want to see on a side. Keeping bus pins together is an example. As we had mentioned, assigning power pins maybe to the last fracture of the partitioning. And then we could do an assignment. And also you can do things like doing sorts on the pins. So the way they're sorted in the table here is the way that they're going to appear on the symbol. So I'll do an assignment and go back to the excuse me, to the symbol partitioner, and here's our symbol created. So at this point, this symbol could be exported to a CAD system. I'm going to make a little change here just to show you an example, but so we could work with that maybe. You can also, this is a full editor, so you can select things. You could select pins here, move them around. You could add text. You could do a lot of different things. But let's say I wanted to be more interactive with this and create my own graphics for this particular symbol. So the way I would do that, I'm going to go back over to the main spreadsheet, go back to my tools, and I'm going to unassign the pins. And now to be a little bit more interactive, I'm going to go to the symbol partitioner, but this time I want to do a select. So I'm highlighting the menu pull down to select and drop. And what that does is it just, whatever's highlighted there, it allows me to just drop those pins onto the logic symbol. So if I highlight a couple pins, I can drop those. If I wanted to grab the entire I/O bus, for example, here, and drop those onto the symbol. I can do that. I'll put the data bus on the same side. Now, let's say I wanted to have a little bit bigger gap between the I/O and the data. So what I could do is I could just change the height of my current symbol, make this larger in some way, and now I could just drag those pins, put them there like that. Going back to the full view, read writes and output, so I could put that over here as well as EL. And now my address bus, I'm going to take those and drop those over here. And I have a couple more pins that are not power or ground. I'll put those again on this side. So there we have the one fracture of this particular component, and it was manually created or interactively created. So at this point, I have some VDD, VSS, etc. So I'm just going to create a new symbol, and now I can just grab my VDD, put that on the left, put the ground on the right, and we still have a VPP pin, so I'll put that here, and then I'll grab the multiple NC connections and put those on the top. So there we have our two symbols that we are going to then export to our CAD tool. So clicking export, I could do a capture pin table that would allow me to use a command inside of capture that creates parts from spreadsheet. I can also just do a capture command that's going to create an XML file that I can then run as a bat, and it'll create the OLB for me automatically. And that's the one I'm going to do. And you notice there that there are some other export options. So I'm just exporting that, and I'm going to invoke capture. And then open up the library that it created of that particular component. So if I do a file open, OLB, this was put into my symbols. I have a library for that particular component. Cypress Web was the part. And if I zoom in, I can go to that part, back to the gate 1. So that's how easy it is to create a symbol. This one, 64 pins. You notice that it did retain all the spacings that I put in my canvas in EDABuilder. We got the correct pin names, pin numbers. You know, all these pins have their unique properties. That all comes across. A couple of things that I didn't mention when I was building these parts is just some of those other editing capabilities that you would have. If I went to the editor, if I wanted to do something like maybe select some pins here. Maybe I wanted to give them some additional annotation. So maybe I wanted to put an address comment or graphics on those. Oops, let me do that again. So we can put some graphics on there. We could do that for the, well, anything in there. We could put text in if we wanted to just put some simple text, just text. That was ugly. Let's make it all caps. And maybe change the height to something like 100. And it'll put that text up there. And then we could go through a process of actually relocating that to drag it to some other location. We can also do things like some people have the requirement to create IEEE logic symbols where you might have a cutout in a part. So you could do that. You could put the cutout with a line across to segregate your chip into functional blocks if you wanted to. All right, so that's kind of the symbol creation. And here's something that's really important. Notice that my window on the left is blank. Why is that? If I go back to my main spreadsheet, I have all the pins there. There's going to be 64 pins. And I'm just going to do something here to show you of another feature going forward here. I'm going to delete a couple of these pins. So I only have 62 now out of the 64 that this particular part was created with. But the other thing I wanted to show you here is that going back to the partitioner, this field or this left pane is now empty. I didn't really show it as I was doing it, and hopefully some of you caught it. but as I was grabbing pins and dragging them over to the symbol, they were being removed from this window on the left. Conversely, if I wanted to select pins here and do something like this and put them back into the floor planning, I can do that. So I've removed them from there. Maybe I wanted to put the I/O pins and these other two pins on a third gate, so I could create a new gate and then drag those pins to that logic symbol as well. And they get removed as you drag them across and put them on the logic symbol. Okay, so let's go forward now. Let's go back to an environment where we want to actually talk about the PCB Footprint Editor. So here I've selected the PCB Footprint Editor, and what I really want to do is build an IPC compliant part, starting with a calculator that has the fields that are appropriate for that particular package style. So what I would do here is I would actually just do a load of a particular template, whether it's a VGA or a electrolytic cap or chip cap, chip array, dips, those type of things. I'm going to just select the QFP since that's what was used in this particular data sheet example. And I'll do a load new. And so now we have the symbol. And at this point, we can start to do some filling in of data forms from the data sheet. This is IPC compliant, so we have basically three technologies. We have nominal, maximum, and minimal spacing for IPC 7351. We're creating component names, etc., that are based on the IPC standard. That's the Preferences tab. I could do layers, so for example, if I wanted to show my silk screen or if I wanted to show the assembly view, I can turn those on or off. They'll get calculated and move forward with the export into your host CAD system. The most important window probably is the component window. And so here is where you would take the data from the data sheet for the QFP that you're working on and just plug them into the fields that are applicable to that particular template style. And it's just a matter of, let's say I just change these numbers here. You'll notice that I got a red icon up in the top. That's just a refresh button. So now I've changed the number of pins from 16 on a side to 12 on a side. So it's just that easy to change elements and then update your graphics with your new numbers. Some other things that you can do, I mentioned here that this form is really aligned to the particular calculator or template that I've selected. As an example, let's just go back and open up a different one. So if I open up something like a QFN, that's going to have different fields. Or if I go back and let's open up the electrolytic cap. So now you notice that our fields here are always changing to match the type of component that we're trying to build. So the dimensions are again aligned to that particular style of component. And you can just select multiple different things if you're doing a chip resistor, a chip cap, diode, whatever it might be. Just because I can, I'm going to select, excuse me, a BGA here. And so one of the other things that you have the capability of doing is you can actually identify by selecting an area. Maybe this particular BGA doesn't have all those pins, so I can actually tag those, and now that's how you would remove pins from a particular package. And you can do that by a window, you can do it individually, and then this is what's going to get output to your host CAD system. So this is the one we're going to work with, the QFP. This one happens to match 64 pins to that particular part. All right, some other things that are pertinent here. I want to just show you one other thing. So I'll go back to that QFN. So what are some of the other tools in addition to having shape editors where you can actually, for your thermal pads, etc., you could modify the shapes, or if you have pins that have unique shapes onto them, you could create those as well. You also have the ability to change your pad stack style. In this case, we're working with a pad stack that is an oblong. We could change it to a rectangle, or we could change it to a D shape. So depending on your host CAD system, there might be certain types of pad styles that are going to have to get created as shapes, and we handle that all automatically. So if we exported this right now, a D pad is not a supported Allegro footprint style, so we would just create these pads as shapes, as well as the other information for paste masks, solder masks, etc. And the other thing we could also do is, if we wanted, we could actually go to the pin table, and we could go to a pad stack modifier that would allow us to actually do some unique graphics on these. So if we wanted to change them to rounded rectangles as opposed to just a D shape, we could choose the particular pad that we wanted to have. We could say that we want to change all corners. We could add the radius that we wanted, and then we could round the pads, and that would round all 4 corners in this particular case. So you can get those custom pad shapes. So I guess let's just take this particular part, and as Ed mentioned, we have the preferences for the 3 IPC standards, and depending on which standard we have selected, we'll get the option to select the toe and the heel if we wanted to do some customization. We can also do our own unique settings for things like silkscreen width, assembly width, those type of elements. I'm going to go back to a window that's configured for both symbols and footprints, because I want to show you one of these other elements. So if I go back to the spreadsheet and I do a tool and annotate the spreadsheet to the footprint, I can select the data that I wanted to. Probably more visual is if you were doing something like a BGA and you just specified the banks and highlighted the banks, or if you did a color map of your power and ground or your voltage pins, so you could do that as well. Here I'm just going to grab some pins, annotate it to the footprint, and then in the footprint I could say I want to graphically report elements that are missing pin assignments. So if I do a display, you'll notice here that we have some pins that are highlighted, and the reason for that is they're actually missing from the symbol. If you recall, I deleted 2 pins because I wanted to show you another function. So these 2 pins right here were removed from the data sheet and from the main spreadsheet, so they're highlighted. These other pins, well, they weren't part of a logical pin connection on the logic symbol either. They're thermal pad, which could be defined when you export this as just a shape, or it could be a pad stack, but you may or may not want it to be an electrical element. You have that choice when you export. And then the fiducials, obviously, they weren't in the spreadsheet as well. So that's just the kind of checking that you can do. You can also do checking where, if you wanted to, you could do highlighting of pins between the symbol, the spreadsheet, the footprint. So by just selecting elements, you could do things like probing the pins, that type of thing. I didn't mention it while I was doing this logic symbol, but you can also edit properties. So here are the properties that are assigned to this particular symbol. I didn't, when I output it, I didn't assign a physical footprint. We could do that, give it some unique footprint that we search from the library, or we could take the footprint that's actually in the active window here and attach that to this particular part. You also have the ability to do different configurations for the style. So if you wanted to do, if you didn't like these long pin styles that you're getting there, we could change what we call whisker to some other size. So in this case, it just shortened those up. So if I zoom in here, I just can't do it when I'm in that window. So it just made short pins in that particular instance. So those are some of the configurations that you can do. You can set up text sizes and offset for your text, etc. So I think that kind of just brings us to a point where I'm going to jump back to the PowerPoint presentation. and go to the next topic. So hopefully many of you are at the latest release of the Cadence software version 16.5, and one of the features there is, actually I think it might have become available at 16.3, I'm not sure, is the marketplace, which really provides an excellent resource of all types of information, including app notes, white papers, library content. You can download simulation models, and there are now also apps that tie into either Capture or Allegro. There are two apps there if you go to the Marketplace store now that you'll see as Symbol Gen and Footprint Gen. And what these two apps are, these were our introduction into this technology of library development. Symbol Gen would be logic symbols exclusively interfacing or launched from within OrCAD Capture, and Footprint Gen is the footprint generation capability. And when I get done with this slide here, I'm going to go back to the tools for a second, because I didn't really show you taking those forward into the post-CAD environment, which I'd like to do. So anyway, these are a subset of EDABuilder. They don't have the same robust feature set that EDABuilder does, but it's a good place for maybe you to get initiated to this type of technology. So any investment that you make in buying these particular apps that you can do from the store directly would be fully credited as you might want to upgrade to the EDABuilder. And before I conclude here, let me just go back to EDABuilder, and I'll go back to, well, we'll do the footprint first here. So if I go to my footprint window, and as I had mentioned, I can export this by selecting the Export tab. I probably might want to do a save of this particular footprint first, so I can save my package envelope. It, again, is going to assign an IPC footprint name. I could change that and just call this my part if I wanted to, and assign it to a library. We have a package library, so I'll save that. When we were doing that same thing on the logic symbol, I did take that forward into the Capture environment. There were other export options there. Well, those same kind of export options would exist here. So if I wanted to go to Allegro, I could do that. If I wanted to do some comparison for just doing a text report of things that are different between the logic symbol and the footprint, I could select those here, or I could go to some other vendor outputs. So in this particular case, I'm just going to export out to, in my case, I'll launch OrCAD. So this is OrCAD PCB Editor. And what it's doing is just running through the sequence of scripts that's going to create this particular footprint. So it's really just push button that I have to do after I've done the filling in of the tables, the dimensions from the data sheet. So here's my Allegro footprint. That simple. And again, if these pads, right now I think these tools, these pad stacks are probably oval, so they are a supported Allegro element. They're oblong. So if they had been something that was a unique shape, they would have gotten defined as a shape, and then the geometry down here would have been filled in as a shape, and the graphics for that predefined. And so we build all the pad stacks and all the parts. So the other thing about that is I'm just, at this point, creating the necessary elements to build that part. That's stored in that envelope that we were talking about. And really, I can keep that separated from the ability to release these to a library. So what this will do is this will identify all the symbols, whether they be shape symbols, maybe there might be some mechanical symbols or something like that, as well as the draws and the PSM, and I could tell it whether or not I want to copy these to a selected library. And there might be times when you generate parts when you're going to have duplicated a pad stack and you don't want to overwrite it. And so you don't have to choose that to be overwritten if you don't want to. One other thing to mention is that if you, or as you create parts, you might want to save them to a library. So both for the logic symbol and for the footprints, let me go back to the configure both here. So I have the ability to go to a directory of parts. So here are parts that may have been created before. So if I wanted to open up a particular part, I could just go to that XML that gets created. And I don't really want to save that. So what I did there is I just opened up that particular footprint that I had saved earlier. And the reason you might want to do this is to take this particular package, edit it, and create your own new footprint. So you have the ability to recall libraries. And again, you can do the same thing for your schematic logic symbols as well. So while I'm at it, I might as well do that. I'll just go back to the symbol builder, and I'll do a file, directory of parts here. I don't have that many that I've created, but if I wanted to go to a particular part, I could go to that part, open it up, and show the symbol partitions. So this one is made up of multiple, I think there's multiple banks on this particular component. So that's kind of it. Going back to the PowerPoint presentation. I don't know if you read the quote by Manny Marcano on one of the earlier slides. Manny Marcano, being the president and CEO of EMA, have mentioned that we can be much more effective using our time to do just non-administrative tasks, being an individual that can use our engineering training and be more productive. So really, I mean, this particular tool as a self-contained application can actually allow you to offload some of your library development to people that can just take forms or data sheets and plug the numbers into forms. It's really that simple. And you can have templates that you've created that meet your company standards or are IPC 7351 compliant, and it's going to do the rest for you automatically. So we want to thank you for attending today, and if you'd like more information about today's webinar topic, EDABuilder or apps, or other products or services offered by EMA, please contact us. I think that brings us to just about the top of the hour. Again, thank you very much. And Kelly, I'll turn it over to you to do whatever is necessary.
Okay, Ron, we just have a couple of questions. I know we have a lot of questions here coming over the computer. I'm going to ask a few of them now. If I don't get to your question, we're going to contact you individually after the webinar to answer your questions and discuss it. So Ron, just a couple of quick ones. We have the question, how is the pin spacing grid and text size predetermined?
The organizer